Following are the types of relationships in MDG. In rental car data model, we use leading, qualifying, and referencing relationships. Following are some key facts about relationships in MDG. We will discuss these key facts with examples from the rental car implementation. We will discuss the relationship types and their effect on MDG design time, table generation, and runtime behavior. Let's start with the leading relationship. We have three leading relationships defined here. All three of them are from the Type 1 entity rental car 1 to the three Type 4 entities in the data model. When the data model is activated, MDG tables are generated. We have seen this several times in this e-learning. During activation, the relationship definitions affect table generation to a great extent. Let's start with the effect of this leading relationship on the generated tables. This is the generated check table for the Type 4 entity rental car parking 4. Notice the key column rcar ID. Where in this Type 4 entity definition do we have rcar ID? The rental car parking 4 entity definition does not have rcar ID as a data element. Well, Type 4 entities cannot have a data element defined. We have seen this before. rcar ID is not even an attribute in the entity. Even if it were an attribute, attributes do not show up as key fields in generated tables. We have seen this before as well. So where do we get this key column from? It is the direct result of the leading relationship of the Type 4 entity with Type 1 entity. The Type 4 entity automatically inherits the Type 1 entity's data element by virtue of the leading relationship. The data type is from the data element definition from the Type 1 entity. Notice the column name for the key column. MDG framework has a specific format to generate the key name. In general, Type 4 entities get their primary keys from relationships. Here, all three Type 4 entities inherit the rental car ID as their primary key. To understand the runtime scenario, I created a master data with the following data. Following are the values in the tables for the rental car ID 6. The rental car ID is populated in all the Type 4 entities. We have one qualifying relationship in the data model, and it runs between the Type 3 entity locations 3 and the Type 4 entity rental car locations 4. This results in a second key column in the Type 4 entity. Location name is the data element in the Type 3 entity. It is the data element for the key column. Notice the multiple rows of location data for rental car 6. This is a reflection on the cardinality setting in the relationship. Each rental car master data can be extended to multiple locations. The comments attribute is added specific to each location. This is another way to represent relationships involving the rental car locations 4 entity type. It has a leading and a qualifying relationship, both directed to the Type 4 entity. The generated tables of the source entities themselves do not undergo any change as a result of the relationships. Finally, we have the referencing relationship. In rental car data model, the referencing relationship runs between parking 2, the Type 2 entity, and rental car parking 4. This is the generated table for the Type 4 entity, rental car parking 4. A column of type ZR parking type is added to the Type 4 entity as a result of the referencing relationship. But notice that the column is not a key column. Also, the name of the column here is structured differently. The column name in this case is derived from the name of the relationship. In the other relationships, the relationship name is not referenced in any other settings. This shows the data in rental car parking table. Considering the cardinality of the relationship between the rental car parking and the type 1 entities 1-to-1, we have one row of data for each rental car ID. The ZR parking type column has the parking type selected by the user from the drop-down list of parking types. We discussed the SU types in detail in earlier sessions. We saw that the type 1 and type 4 entity types save master data created by user, while the type 2 and type 3 entity types provide reference data to the other entity types. In rental car model, the locations 3 and parking 2 entity types provide the reference data by qualifying and referencing relationship respectively. In summary, we saw the effect of various relationships on table generation. We also saw how the runtime data is populated in those generated tables. There are of course other combinations of entity types participating in a relationship. Following is an extract from the material data model. Notice that we have several leading relationships going from a type 3 to a type 3 entity type and from type 3 to type 2 entity types. In future sessions, we will use what we learned so far to implement common customer requirements. These implementation scenarios will help us further expand our understanding of MDG fundamentals, help make design decisions, and advise customers with their master data decisions.